This is AP Precalculus. We're on notes for topic 2.4, logarithmic function context and data modeling. We have a cool dot plot up here, and bear with me as we have a bit of reading. The average salary for a church pastor across the U.S. increases as the size of the church increases. The graph above shows the average pastor's salaries for various church sizes. Okay, so when the church size is about 5,000 people strong, your salary is a little over $160,000. Whew. We can clearly see a pattern in the data. Yeah, the pattern goes like that, right? It's pretty clear that it's going to probably level off up here. But the models we have used previously are not appropriate for this data. The grow above displays a large rate initially, like look how steep that is. But as the church size increases, we see the rate gradually decrease. Yeah, it's now more of a flat line instead of a steep line, right? The data above appears to be logarithmic. Just as we see with other types of functions, linear, quadratic, exponential, etc., many real-world scenarios follow a logarithmic pattern. Outside the salary data in the graph above, logarithmic patterns are found in the way we measure earthquakes. These are the key words here. This will help you determine what sort of problem you have just based on this context. Earthquakes, sounds, acidity, and other contexts. As a result, we have a need to create logarithmic models for these types of data. And we have this information. So for a given data set, if input values appear to change proportionally, so input values, again, those are like the x coordinates, right? So as the x coordinates appear to get multiplied, we're assuming that the y values, the output values here, so this is the y values, are equal length. So the y values are being added and the x values are being multiplied. It's nothing new. We've already talked about this before. Then a logarithmic model is appropriate. So we have these two forms for a logarithmic question. It's either going to be a natural log or a log base 10, it appears. So they don't have any other bases besides base e and base 10 for the modeling of this, I was going to say unit, this topic 2.14. Only two bases that we have to worry about. Excellent. All right, so what do we have? Selected values of logarithmic function are seen above in that table. And we need to write two equations, and then we're going to use those equations to solve for a and b. It's interesting that we have to do this because the only way that I know of actually taking a logarithm is by using a calculator. So couldn't you just use regression? Okay, whatever. Let's pretend that we didn't have a calculator and we'll use only a calculator at the very end here. So two equations. So again, I'm going to basically copy u down over here. I'm going to say, it's going to be a plus natural log. Okay, so it's going to be y is equal to a times b times natural log of my input. And I'm going to write that again. Y is equal to, and maybe I'm not going to do a y because that's my output. I'm going to put an output right here. So I'm going to come over here and say my output is over here. My output is equal to a times b times natural log of my input. So what is my input? This is the input. So 2 is one of the inputs, 5 is the other input. So I'm going to say 2 is an input, 5 is the other input. When I input 2, I get out 3. This is my output over here. So 3 is going to be my output. Let's come over here and say 3 is my output. And of course, if I plug in 5, I should get out a 7. If I plug in 5, I should get out a 7. So those are my two equations. Sometimes we can simplify these. Natural log of 2, can't simplify, okay, so in this case, we can't simplify any further. That's as far as we can go. Maybe in another example on this homework will be, or lesson, I should say, for the notes, we should see if we can simplify that. Okay, so now we need to find the values of a and b. So I need to somehow combine these two equations. Usually in algebra, there's only two tools at our disposal for combining equations. You can either do substitution or elimination. And either one will actually work in this case. The notes are doing elimination. And that's usually the one that I favor as well. I like elimination, which means you kind of like take that one and you subtract that one. They line up nicely, so I think it should work. So let's go ahead and rewrite these down here. I'm going to rewrite them. One of them is going to be one color, the other is going to be the other. So let's say 3 is equal to a times b. Is it a times b or a plus b? Oh my goodness, I've been copying it down wrong. It's supposed to be a plus b. I apologize. Let's come back here and fix that. So this should be a plus b and a plus b. Okay, so down here it should be a plus b times natural log of 2. So a plus b times natural log of 2. And the other equation I'm going to do underneath this, we're going to call this thing let's do it in red, sure. We'll say 7 is equal to a plus b natural log of 5. So I'm going to subtract one from the other. Kind of makes more sense to subtract a smaller number, but whatever. I'm gonna subtract this one because I wrote it second. So I'm gonna go down here. So I'm gonna subtract this, subtract this, subtract this. Essentially what I'm doing here, I should be careful. I'm multiplying both sides by a negative. I'm multiplying both sides by a -1. And when I do that, it turns into this. I'm gonna go ahead and erase that so I don't have to rewrite it all a second time. I essentially have said that this is now a negative, that's a negative, and that's a negative. Everything has been multiplied by a negative. That term, that term, that term, all three of these. And now I can do, okay, what's 3 minus 7? That's -4. There's an equal to sign. Oh, this is nice. A and A are gone. A minus A, there's nothing left. And unfortunately, we have to rewrite all of this stuff. I have a B natural log of 2, and then I'm subtracting a B natural log of 5. Okay, so I need to continue down. The nice thing that I'm noticing is we have eliminated an A. That's the whole point of elimination. You're supposed to eliminate one of the variables. So we need to solve for B. So let's factor out a B. Let's essentially do this. I'm saying, okay, factor out a B, factor out a B. And what's left over is B is being factored out. I'm left with a natural log of 2 minus a natural log of 5. Natural log 5. And then left-hand side hasn't changed. It's still a -4. And now I have, this is just a number. I can type this into my calculator and just get a number. So pretend that number is like 3. I don't know. I essentially have 3, all that's 3 times B. If I have 3 times B, the thing to do is divide by 3. I'm going to divide by this on both sides. And I've run out of room, so I'm going to come back over here and say, we're going to work up here. If I divide both sides by that, I guess I can kind of show it down here. I'm going to divide the side by natural log of 2 minus natural log of 5. Then I divide this side by natural log of 2 minus natural log of 5. And you get B by itself on the right-hand side. And what do we have over here is -4 all over natural log of 2 minus natural log of 5. Done. The answer key tells me that I'm supposed to now use a calculator to evaluate this. Do you need to, though? I mean, it makes the problem much easier, not more easier. So let's go ahead and do that. I'm going to say, okay, let's pull up our calculator, and let's type in -4 divided by, start your parentheses now because all this stuff is in the denominator. I'm going to say natural log of 2 in the parentheses minus natural log of 5 in the parentheses and in the parentheses again, and we get that number. So it's an approximation now, so I'm going to do wavy equal to sign for my approximately equal to 4.3654. Why did I do 4 decimals instead of 3? Because natural logs usually are rounded to 4 decimals that I've seen in my experience so far. Okay, how do I store this to my calculator so I have it exactly? I'm going to hit the store button in the bottom left above the fraction beneath the natural log function. And I'm going to store this to, well, this is the B after all, so I'm going to hit alpha and then the apps button for B. I'm going to store this answer as B. And then just in terms of our equation over here, I can choose either this equation or that equation, whichever one I want. I'm just going to randomly select that one. And I'm going to rewrite this, but in the place of this B, I'm going to write 4.3654. So I'm going to say, now, rewrite this. This is going to be 3 is equal to A plus B. So I'm going to leave this space for B. B times natural log of, what was it? Natural log of 2. And again, the B that I have is, I'll bring this down here and say this is 4.3654. And if I'm seeing that all this stuff is it's just a number that's being added to A. So what I really need to do is I need to subtract that number. So I need to say, okay, just go ahead and do minus 4.3654 natural log of 2 on that side, which means the left side. I also, I don't know if I can write this all in here, minus 4.3654 natural log of 2 on this side. And there's my answer. A is equal to 3 minus 4.3654 natural log of 2. And luckily for us, that is just a variable that we can store, and we can figure out what A is roughly. We can say that, I want to say that A is approximately, wavy equal to sign, that was a terrible wavy equal to sign, is approximately, And then I'm going to type in my calculator, 3 minus, and now to recall that value, I'm going to hit alpha apps again. So 3 minus b, and then I'm just going to type in, you don't have to hit times, you can just type in natural log of 2. And you get, we'll write this down 4 decimal places, it's negative 0.4 decimal places, 0.259. I'm noticing in the answer key, Ted Gott has decided to truncate this and call this an 8 instead of a 9, and I've decided to round it. That's fine. Cool. So we found our values of A and B. I should probably, box those because they're important. So here's B is about that value right there, and A is about that value right there. Nice. Okay. Let's go ahead to the back side. I don't know if I need my calculator anymore. Yes, I will. I'll leave it up here. All right, so I'm noticing that the church information right here from the table matches exactly that right there. So it's kind of interesting that we're seeing the data in a different form. We have this table that talks about that church size and pastors for their salary again. So what does it tell us to do? So use the regression capabilities of our calculator to find a function that is of that form. Okay, so the hardest part is entering all this into the calculator. So I'm going to hit stat, edit, and then I need to enter all of this stuff for my x coordinates. I'm going to say 75, 120, 250, 300, 450, 650, 900, 1,500, 2,500, and 5,000. And if I make this slightly bigger, I can see those values better. Okay. Up here for list 2, I'm going to have the y coordinates 42, 58, 70, 79, 88, 95, 110, 125, and 138. That all, oh, and then there's one more, 175. I'm like, we had a number on the left. Okay, we have a number on the left and on the right. So I think we're good there. Hopefully I didn't enter those wrong. I don't see any glaring mistakes. Okay, so once we have this data, we're going to go back to the stat button and then go to the right for the calculation test, and we're going to go down to a linear regression. Notice that over here it's talking about an LN, a natural log. So I'm going to come down here to option 9 where it says natural log regression. And hit enter. What do we got here? Okay, so I'm going to store my equation in alpha trace y1 and hit enter. All right, so those are the values. Okay, so we did it. Let me write down my answer. I'm going to say that our function s of p is equal to a, which we found as negative 91.542. I'm just going to leave it with 3 decimal places, plus b, which is 29.909, 3 decimal places again, and then natural log of p, Don't need parentheses, but I'm going to add them anyway. Okay, so using the model found in part A, what is the predicted annual salary for a pastor whose church size is 500 people? So we know 500 people is about right here. I'm guessing that the answer is going to be about $90,000. So I'm gonna say it's about 90. Let's test. So I'm gonna go ahead and hit second mode to get out. Oh, I just hit clear. Sorry, we don't need any of that. I'm gonna hit alpha trace y1 and start our parentheses, and we're gonna type in 500 as our input. And I'm guessing it's gonna be about 90 and okay, about 94. That's a bit bigger than I thought. Maybe that value was a little bit lower, but okay, that's pretty darn close. It's in the realm. So what I did here is I did S of, and then I plugged in 500. And when I did that, I got 94.3295. I'm just going to put 330 then if I'm rounding. So that's the annual salary. You can say, if our units here are correct, we'll say $1,000. I'm just copying down the unit that was from the table. This is thousands of dollars. Okay, nice. And let me check my answer key. Yeah, they went as well. They did 4 decimal places instead of 3. All right, what do we got for example B? Oh, look at that Greek letter beta. What do we got here? The most common and preferred method to measure sound intensity levels is in decibels. Yeah, you guys have all heard of that. The sound intensity level, B, is in decibels, so stands for decibels, interesting, is a sound having intensity, and intensity is in watts per meter squared, interesting unit there, there's our I, modeled by that function right there, cool. And A and B are constants. I'm guessing we're going to have to find A and B on this question. Noisy traffic has a sound intensity of 1 times 10 to the negative 5, and that's about 70 decibels. And a loud concert is an intensity of 1 times 10 to the 0, I guess, and that's 120 decibels. Use the given data to write two equations that can be used to find the values for A and B. Okay, so it's very similar to the last question where we just have to set up input and output. So just remember that our input, it's very clearly telling us that the input, I is the input. And then this entire piece here, I'll say that entire piece is the output. So the input is I, the input is I. So our input is the intensity. Therefore, our input for the first piece of information is this is the input. We'll say that we're going to do A plus B log, that's technically log base 10, log base 10 of our input of 1 times 10 to the power of negative 5. And this entire piece right here is going to be the output. I could write beta of 1 times 10 to the power of 5 here, but that's redundant. I would have to rewrite the answer over here. So I'm just going to rewrite the answer right here and say the answer there is 70 decibels. So we're going to say that's 70 decibels. And then our second equation, might as well color code these things, do a different color, blue. We input just 1. So I'm going to say this is equal to A plus B log base 10 of 1. And what's the number of decibels? That's, oh, it's right there, 120 decibels. So 120. Okay, we have our equations, and yet again, find the values of A and B. Again, we're probably using a calculator at the very end. And oh, okay, remember how last time I said, is there any way that we can simplify this stuff? And that was my dog barking. All right, so I'm going to use elimination again. I'm just going to say, let's do, oh wait, sorry, I was distracted. Log of 1. Log of 1 is a number, and you should know it because a log base 10 is really counting the number of zeros. Like if it was 100, it would be 1, 2. So 1 has 0, 0. So log of 1, and you should all have this memorized, let me cross off with a different color. Log of 1 is 0, which means this blue function is really, let me write it over to the right, is really 120 is equal to A plus B. That's it. Wait. B was being multiplied by 0, so technically, oh, it's even better. 120 is A, which means finding the value of A, we have it. My first step is A is equal to 120. We actually got that from that last line. And now I don't even need to do any sort of elimination. I can just plug in this value of A into that value of A. Let me see what we get. We're going to get 70 is equal to, there's my value of A plus B log, B times log of 1 times, okay, I can simplify this one as well. And I think I'm going to do that up here instead of down here. So up here, I'm going to say, let's turn this into something nicer. We're going to change this into, that was a 70. So it's going to be 70 is equal to A plus B log, A plus B. And then, okay, I know how to do log of 1 times 10 to the negative 5. 1 times 10 to the negative 5 is in scientific notation. That's what this form looks like. But really what this is saying is you can actually multiply 1 times 10 to the negative 5, and it's just 10 to the negative 5. This is really, do I have any work? I need some room off to the side to write this. I'm going to do it up here. What I'm really saying up here is this is, change to black. No, let's do blue, red, whatever. I have log base 10 of 10 to the negative 5. How do I simplify this? There's a bunch of ways to do this, but my preferred way right now is just to bring the negative 5 down in the front. And I can say this is the same thing as negative 5 times log base 10 of 10. And this is asking, what power does 10 need to be raised to get 10? It's 1. I mean, anytime you have this base and this input, the same number, these just cancel out. And you can say that's all gone. And this is simply just equal to negative 5. So it's a very long-winded way of saying this entire piece here, we can cross it off down here as well and say this entire thing is just -5. It's counting the power that this is raised to. This over here, this was times 10 to the power of 0, which is why that one was a 0. This is times 10 to the -5, which is why that's a -5. You can say it's b times -5, which means down here, I'm going to rewrite this and say it's minus 5b. That's the same thing as b times -5. It's -5b, right? And all I have to do now, I said this value is a, because back here this said 70 is equal to a. This is 70 is equal to a, and the value of a is 120. So this value is going to come down here, and we have 120. And I can solve this pretty simply. I can subtract 120 on both sides. So this could be -50 is equal to -5b, and then divide both sides by -5, and b is equal to 10. So value of b is 10. Value of a is even easier, 120. Nice. All right, and then C, the human eardrum can burst. Ooh, that doesn't sound fun. When you reach this intensity level. So we haven't even seen anything close to that. We have an intensity level of 1, which is times 10 to the 0, 10 to the -5. This is 10 to the power of 4. Wow. According to the model found above, what is the predicted number of decibels required to burst the human eardrum? Interesting. Okay, so what I need to do here is I need to essentially use A and B to plug into my formula. Remember, my generic formula is still, I don't have it written anywhere, but my generic formula is my output, which I think is there a letter for output? It's beta, right? My output, my beta, whenever my input is equal to A plus B log of that input I. So in this case, is that the right way of doing beta? Beta of my input is equal to A, which we know is 120, plus B, which we know is 10, times my log of my input. So there's the formula that I have found using these two values up here. And now I need to plug in my intensity. My intensity is 1 times 10 to the 4. So I'm going to come down here and say that when I do my beta of 1 times, let me color code this to make it look cool, 1 times 10 to the power of 4, that is equal to 120 plus 10 times log of that 1 times 10 to the 4. 1 times 10 to the 4. And I know what this is. I don't even think I need a calculator for this question. Go away, calculator. Because I already told you guys that the shortcut here is this entire thing is just that number. So all of this is going to turn into a 4. Let's go ahead and say that. That entire thing is a 4, which means my equation, I'm running out of room, I'm up here. My equation now is I guess we'll call this thing beta of 1 times 10 to the power of 4 is equal to 120 plus, this is going to be 10 times 4, which is 40. So this is equal to 160. So 150 decibels. Is there a letter that means decibels? I'm just going to say decibels. Interesting. Okay, so we solved that. I do want to read this fun fact, though, because I didn't see that. The word decibel comes from two pieces. Deci refers to the fact that the level of sound is multiplied by 10 as a part of the formula. Multiplying by 10 each time is the reason that we have log base, you guessed it, 10. And then Bell refers to Alexander Graham Bell, the inventor of the telephone, after the person. Decibels are named after the inventor of the telephone. Very cool. Minor fact that's personal to me. I measured Lily's scream, or I guess my father-in-law, soon-to-be father-in-law, measured Lily's scream, and the loudest human-made sound on Earth is 135 decibels. Lily comes in at 120 decibels, so she's close-ish to the world record, and it's also kind of close-ish to the sound level that it'll take to break my eardrums. I just thought that was interesting to point out. All right, that concludes notes for topic 2.14 for AP Precalculus, logarithmic data modeling. There's a back page, there's a front page.